going to fly through algebra here. So this is ordinary level project maths. There's three things we want to look at. So first, I'm just going to call it numeracy. That's kind of messing around, being able to work with numbers. Because basically, algebra is the same thing. You need to be familiar with like BODMAS and working with brackets and that kind of thing. Because then the same rules that apply when you're dealing with numbers also apply when you're dealing with algebra, when you're dealing with x's and y's. So we begin with that, since if you don't know those building blocks, the other stuff doesn't make any sense. Secondly, we're going to look at simultaneous equations. Secondly, we're going to look at simultaneous equations, in particular linear ones. And finally, we have quadratic. If we have time, there's two other bits that I'd like to throw in as well. That would be inequalities and algebraic fraction. But we'll see how it goes. So numeracy, what I mean there really is working with expressions. So say you have 1 plus 3 multiplied by 2, well, that's equal to 1 plus 6, and that's equal to 7. It gets more complicated when you have expressions like 1 minus 4 plus 3, because that's equal to like 1 minus 4 is minus 3 plus 3 is equal to 0. And that's the correct answer. What people can do is say 1 minus 4 plus 3, that's equal to 1 minus 7, because they do 4 plus 3, and that's equal to minus 6, which is wrong. You can get around that by thinking of minus 4 as adding the number minus 4, adding a negative number. So if you write that as 1 plus minus 4 plus 3, well, then you can't go wrong. Then when you add 3 to minus 4, you end up with minus 1. Minus 1 added to 1 is equal to 0. So one way to remember whether you're doing it right, to avoid the pitfall of this, where you end up with the wrong answer, is to think of minus 4, to write minus 4 as plus minus 4. So minus 4 being like a negative number. a handy way to check, though you can't do this in the exam, is use Google. So can check in Google. So just type in, 1 minus 4 plus 3, and Google knows how to interpret that. So that way you can see what the correct answer is and learn that way. Again, this is a turbo class, so I'm not going to go into it in that much detail, but you've probably heard of BODMA. So you do the fact that you work out what's inside of a bracket first, then O is an order. So if you have 2 squared, you work out this, you square it before you multiply by a number beside it. You do division and multiplication before you do addition and subtraction. So that whole thing of what the ordering of working expressions out is has a mnemonic, which is BODMA. You just have to kind of practice and kind of get a sense of how this works. And that's the same way that then algebra expressions with x and stuff are done as well. So if you're familiar and you're comfortable with just dealing with the numbers, then when you do algebra, it all just seems obvious, because you've internalized how the operations and stuff are done, and everything proceeds no hassle. With simultaneous equations, we have, I'll just do an example. You have something like x plus y is equal to 3, 2x plus y is equal to 4. So if we have these two equations and they're linear, so that it's not x squared or y squared, it's just x's and y's, then we can use the fact that both of these equations are true all the time to figure out what x and y are. One way would be to just trial and error. Just try, okay, I'll guess x is 1, y is 4, x is 3, y is 2, and keep guessing, and then plugging those values into the equations to see whether they hold, whether it's true. But that's highly nerve-wracking. I mean, if you're lucky and your first guess is correct, you get straight to the answer. But most likely, you won't. So what I do here normally, and in simultaneous equations in general, is I'd begin with one of the equations. In this case, I'd begin with equation 1, and I'd end up with, I'd reorder it. I'd say x is equal to 3 minus y. So I'd subtract y from both sides. The reason I do that is now I have what x is equal to in terms of y and a number. So then I can just plug this into equation 2. So plug this into 2. So if I do that, what happens? Well, I have 2x plus y is equal to 4, but now I know that x is equal to 3 minus y. So that means 2 times 3y plus y is equal to 4. So then if I just keep going, so I'll do 2 times 3 minus y, and if you're familiar with your numeracy, you're comfortable dealing with brackets, you know that you multiply each of the things inside the bracket by 2. So I end up with 6 minus 2y plus y is equal to 4, which means that 6 minus y is equal to 4, because minus 2y plus y gives me minus y. So then that means that, well, I'll subtract 6 from both sides. So minus y is equal to minus 2, because I subtracted 6 from both sides. So the 6 will go away. 4 minus 6 gives me minus 2, which means that y is equal to 2. Finally, if y is equal to 2, I go back to here. So I know that x is equal to 3 minus y. If y is equal to 2, well then that's equal to 3 minus 2 is equal to 1. So my answer is x is equal to 1, y is equal to 2. And now I would check to see I got it right. So if x is equal to 1 and y is equal to 2, do both these equations hold? So equation 1 becomes x plus y is 1 plus 2, and that is equal to 3. So that's correct. What about equation 2? Equation 2 is 2x plus y. So x is equal to 1, so 2x is equal to 2 plus y, and y is equal to 2. Well, that's equal to 4. So that's correct. So now we're 100% sure we've got it right. The answer is x is equal to 1, y is equal to 2. The only way that we can have something more complicated is if we don't get lucky. If we don't get, so here we had equation 1 where we had x plus y is equal to 3. So it's simple for x is equal to 3 minus y. If we had something more complicated, we could have had equation 1 as 3x plus y. You know, so we didn't have a simple x. We'd do the same thing. It would just mean it would be slightly more messy. We'd end up with like 3x is equal to something. We divide it by 3, both sides by 3, and we'd end up with x is equal to some fraction in front of our expression with a y. It would just be slightly messier, but it's the same process. The other point, or the other thing I want to look at, is that you can also solve simultaneous equations graphically. So we had x plus y is equal to 3. So if you subtract x from both sides, we get y is equal to 3 minus x. We can plot that to get the green line. So 3 minus x is the green line. Now you can do that yourself. Set x is equal to 0. So then plug in x is equal to 0 into the expression y is equal to 3 minus x, and you get y is equal to 3. So you just put a dot at 0, 3. Then say plug in x is equal to minus 1. If x is equal to minus 1, then 3 minus x is 3 minus minus 1, which is equal to 4. So you'd have a dot at minus 1, 4. Then just draw a line through those two dots and you end up with the green line. Now do the same thing for the other equation. So we had 2x plus y is equal to 4. Subtract 2x from both sides and you'll get y is equal to 4 minus 2x. That's the red line. So you draw the green and the red line, and you'd see that they intersect at the point 1, 2. So when x is equal to 1, y is equal to 2. And that's the same answer that we got when we solved the simultaneous equation algebraically. Next we look at quadratic equations. So they're polynomials where the highest order is squared. So something like x squared plus 2x plus 1 is equal to 0. Now, the graphical way to do that is to just plot it and see where it crosses the x-axis. So here we are, we've plotted x squared plus 2x plus 1, and we see that it touches it at about x is equal to minus 1. That just means if you have x plus 1 squared, that's equal to 0 when x is equal to minus 1. If I didn't know that the solution was x is equal to minus 1, well then I'd use trial and error. I'd go x squared plus 2x plus 1. Well, that looks like x plus 1 times x plus 1. There's no systematic way really to do that. The generic way to solve these is by using the formula. So we have ax squared plus bx plus c is equal to 0. Your general quadratic equation, where a, b and c can be any number. So in this case, a is equal to 1 because the coefficient of x squared is 1. The coefficient of x is 2. So b is equal to 2 and c is equal to 1. And the formula is minus b plus or minus the square root of b squared minus 4ac all over 2a. So now I just plug in the numbers. So minus b becomes minus 2 plus or minus the square root. B squared is 4 minus 4, a is 1, c is 1. So 4ac is 4 divided by 2a, and a is equal to 1, so that's 2. So that's minus 2 plus or minus 0, so I won't bother writing that, divided by 2, which is equal to minus 1. So therefore solution is x is equal to minus 1. So whenever you have a quadratic equation, just plug it into the formula and you'll get the answer. And we saw that you can also do it graphically. So that's quadratic equations. Again, we're zooming through things. This is turbo algebra, but this covers 80% of what you need to know. What we didn't touch on was complex solutions. But again, the formula works, and so it's a complex solution if you end up with a negative number here. So you end up with plus or minus the square root of minus 1 or minus 4, and that'll give you a complex solution. You know you have a complex solution when you plot it and it doesn't cross the x-axis. So if your quadratic is something like that, so it actually never crosses the x-axis, that tells you that you get a complex answer if you plug it into the formula. Finally, we also have inequalities. So you might have x plus 3 is less than 5. So inequalities are where you have less than, greater than, less than or equal to, greater than or equal to. The thing to keep in mind is that if you multiply both sides by -1 or by a negative number, you've got to flip the direction of the inequality. So from this we can subtract 3 from both sides and we'll get x is less than 2. Now if you multiply both sides by -1, we get minus x is greater than -2. That's the only thing to keep in mind. Otherwise, you can treat the inequalities the same way that you treat an equal sign. And you can have multiple inequalities where you'll end up with an answer where x is greater than 1 less than 3, or greater than 1 less than or equal to 3. But basically, as I said, treat them like an equal sign, except they flip direction when multiplied by a negative number. And one thing that might help is this lower value is the narrower part. In case you can't remember, oh, is that x less than 2 or greater than? The narrow part, the narrow part is the lower value. The greater part is the 2 points which are wide. Finally, another type of equation that you can be asked is an algebraic fraction. So you have something like 1 over x plus 1 is equal to 3 over x minus 2. This is an algebraic fraction. You can see why. It has x's, so it's algebra, and it's a fraction, hence algebraic fraction. What you do here is you multiply both sides by x plus 1 and then both sides by x minus 2, and you end up with a quadratic. So I'll just show that in action. So this goes to x plus 1 over x plus 1 is equal to 3 times x plus 1 over x minus 2. So I've multiplied both sides by x plus 1. The reason I did that is to get rid of that fraction. So then next I get, well, x plus 1 over x plus 1 cancel. So I have 1 is equal to 3 times x plus 1 over x minus 2. So then I multiply both sides by x minus 2 to bring this up. So next I get x minus 2 is equal to 3 times x plus 1 times x minus 2 divided by x minus 2. Well, now these x minus 2's cancel. So I have x minus 2 is equal to 3 times x plus 1. So now I just manipulate that. So running out of space, that goes to x minus 2 is equal to 3x plus 3, since I'm multiplying 3 by x plus 1. So now I can subtract x from both sides. So then I'll end up with minus 2 is equal to 2x plus 3. Now I subtract 3 from both sides. So I get minus 5 is equal to 2x. So then x is equal to minus 5 over 2. This was a simpler example because you can also have algebraic fractions where you end up with a quadratic equation. But essentially you just tidy it up. You try and get rid of the fractions you multiply by the denominator to get rid of them, and once you have it down to a quadratic equation, then you can just plug it into the formula and solve it. So that's a rapid fly through of algebra, which covers the vast bulk of it. Just watch it again to go through the process, the steps, and then practice the equations, practice solving them, and that way you can internalize it and you can feel confident that you know how to do it. Next, I'll put up some past papers, model solutions. So we have model solutions of calculus and algebra problems, and then you're good to go.